velocity time graph. On x-axis we will take time. Why we have written time on x-axis? Because it is a independent variable. So that's why we have taken time on x-axis. And on y-axis we are going to take displacement. Okay, this is the displacement. Earlier we took distance on y-axis when we were studying about distance time graph, but now we are learning about velocity time graph. So on y-axis we will take displacement. Displacement time graph, slope gives us velocity. When we took distance on y-axis, the slope which we got, that was speed, isn't it? Now here we are talking about velocity time graph. So here the y-axis will be the displacement. So the displacement on y-axis, the slope which we will get is the velocity. So what is the velocity? Velocity is equals to displacement upon time. Suppose one object is there and it is in motion. Okay, so we have to take its displacement time graph. From A to B we have to measure. Okay, so here we will take the coordinates. Okay, A coordinates and B coordinates. So this one T1, this will be T2, here X2, and this one, this side I'll write it down, X2 and A X1. Okay, so these are the coordinates. So what will be the B coordinates? B coordinates will be T2, this one. On x-axis the B coordinate is T2 and on y-axis the B coordinate is X2. Same we are going to do with the A. On x-axis A coordinate is T1. So we'll write T1, and on y-axis A coordinate is X1. Okay, so these are the coordinates. So it's simple. Here we are going to use the formula of velocity. So velocity formula is displacement upon time. Okay, here we are going to minus B coordinate with A coordinate. On which axis displacement is written? On y-axis the displacement is written. So we are going to minus y-axis. So y-axis, that is x2 minus x1. On which axis time is written? On x-axis, isn't it? So in the denominator what we are going to take? Time. So that is T2 minus T1. So this is the coordinates, isn't it? B coordinate on x-axis is T2. So here T2, at denominator I have written T2. Yes, isn't it? And on y-axis B coordinate is X2. So this is the coordinate. B coordinate is T2 X2. A coordinate is T1 X1. So if we want to find the velocity of A to B, how we are going to find it out? So it is simple. Here we are going to use the formula of velocity, that is displacement upon time. This is the displacement and this is the time. Here we are going to minus B coordinate with A coordinate. On which axis displacement is written on y-axis. So we are going to minus y-axis, x2 minus x1. On which axis time is written? On x-axis. So in denominator, what we are going to take? T2 minus T1. This one. In numerator part, we are going to take x2 minus x1, and in denominator, we are going to take T2 minus T1. So V is equals to x2 minus x1 upon T2 minus T1. This gives the velocity. Distance time graph gives speed, and displacement time graph gives velocity. Two types of graph as we know in this chapter, that is distance time graph and velocity time graph. We have learned about distance time graph. We have also learned about displacement time graph. Now we are talking about velocity time graph. This is the example for velocity time graph. Let's see what VT graph gives us. A car moves from origin to point A. Time taken by car is 10 seconds. At point A, the car velocity is 20 meter per second. Then the car moves from A to B. How much time did the car take to reach the point B? That is 10 seconds. After 10 seconds, the velocity of that car is 40 per meter second at point B. Again, after 10 seconds, velocity of that car is 60 meter per second. The car took 10 seconds to reach at point C, and the velocity is 60 meter per second at point C. The car started from the origin, time was 0 and velocity was also 0. Then after 10 seconds, the car reached at point A. That time the velocity was 20 meter per second. Again 10 seconds, velocity change at point B. That is, it becomes 40 per meter second. Again after 10 seconds, the velocity change, that is 60 meter per second at point C. Now from point A to B, we take out velocity change. How we find out velocity change? That is final velocity minus initial velocity. Point B is final position, that is 40 meter per second. Point A is initial position, that is 20 meter per second. Velocity change AB is equals to 40 minus 20. This is the final position and this is the initial position, and time taken is written over here. Okay. So 40 minus 20 is equals to 20, and 20 minus 10, denominator we are going to write 10. So the answer is 2 meter per second square. So this is the unit of acceleration. So here velocity time graph gives us acceleration and distance time graph gives us speed. Displacement time graph gives us velocity. Okay. Now to find out B to C velocity change, how we are going to find out? Velocity change is equals to final position minus initial position. So here C is the final position, the velocity is 60. B is the initial position, the velocity is 40. So velocity change formula is final position minus initial position. So C is the final position, so the velocity of C is 60, and B is the initial position, so the velocity is 40. 60 minus 40, 20. Okay, and denominator we have written the time. Okay, so 30 minus 20 is 10. So the answer is 2 meter per second square. Okay. If you divide this 20 by 10, the answer you will get 2 meter per second square. VT graphs gives acceleration. Acceleration is equals to change in velocity upon time taken. In DT graph, how you find out uniform motion? You get a straight line. We can say it as uniform motion because the slope is in straight line. In distance time graph, the slope is in straight line. How? Because it has equal distance and equal interval of time. That object travel in equal distance and in equal interval of time. So it is called uniform motion. Okay. But in VT graph, you can see straight line is going on. This is the VT graph. The straight line is going on. The slope is in a straight line. Okay. So can we say this is a uniform motion because the slope is in a straight line? No. The answer for this is no. We cannot say this is as uniform motion though the slope is in straight line of VT graph. In uniform motion, speed and velocity is constant. In DT graph, we plot a graph of equal distance and equal interval of time. For example, you can see here, this is, that is car. A car moving from A to C, C to D and D to B. So the distance is 2 meter per second and the time required is 2 seconds. So A to C, time taken is 2 seconds and distance is 2 meter. From C to D, time taken is 2 seconds, distance is 2 meter. From D to B, time taken is 2 seconds and distance is 2 meter. So how you are going to plot this? Yes, it is a distance time graph. So from, we'll take this point as a, this point as A. Okay, the starting point we'll take as A. So from A to C, time required is 2 seconds and distance covered is 2 meter. So on y-axis we'll locate it and on x-axis we are going to locate 2 also. So intersect these 2 points, we get the C. Okay. In next 10 seconds, the car move further, that is from C to D. That is time taken is 2 seconds and the distance covered is 2 meter. So from C to D, what you are going to do? You are going to add. So here 2 plus 2 gives you 4. So on x-axis, the time taken by the car is 4 seconds. Okay, and the distance covered on y-axis is also 4. Okay. The same you are going to do with the D to B, because here 2 seconds time taken. The interval time is of 2 seconds and the distance is also of 2 meter. So equal distance and equal interval of time. So this is a uniform motion. This is distance time graph and it is in uniform motion. The slope is straight because the graph, the motion is in uniform motion. Okay. The distance time graph is linear or straight, and for non-uniform the graph is curved. Okay. Velocity time graph. This is also a straight line. This line is also a straight line. The slope is in straight line, isn't it? So can be this is uniform motion? Yes? No. It is not an uniform motion. Okay? Because an uniform motion speed is constant. But here the speed is changing. In this example, at first 10 second, the position of A is 20 meter per second. This is the velocity of the car. Okay. In next 10 second, the position is 40. The velocity is 40, that is B point. Again next 10 second, the velocity is 60, that is C point. Means after 10 second interval of time, the velocity is increases. Yes, 20, 40, 60, 80, 100, 120. The velocity is in increases state. Here the velocity is not constant, it is increasing. Yes, if I take 20, here also 20, again here 20, again here 20, then we can say it as uniform motion because the velocity is not changing, same, that is 20, 20, 20, 20. Yes, so it is uniform motion because velocity is not changing, and here 20, 40, 60, 80, 100, 120, the velocity is changing. So it is not uniform motion. Uniform motion means equal interval of time and equal distance. Okay, but though it is not uniform motion, but it is uniformly accelerated motion. Why? Because at every point throughout the journey, acceleration remains constant. How? The car is in uniform velocity, means the velocity is changing. 20 meter per second is 10 second. So after each 10 second, the velocity is changing. So that's why it is called uniformly accelerated motion. This is the example of uniform accelerated motion. Velocity is changing but uniformly. If here the velocity is constant, then you can't find out the acceleration. We have learned that acceleration happens when velocity changes. Here from A to B, B to C, how we are finding the acceleration? When there is a change in velocity. Though it is a straight line, it is not uniform motion. Here uniform motion is not there because velocity is changing. How it is changing? In equal amounts. Uniform rate. So this is the example of uniformly accelerated motion. In your textbook, uniformly accelerated motion example is given. Table number 8.3. So you can see here at 5 seconds the car velocity is 9. Again after 5 seconds, that is 10 seconds, the velocity of car is 18. Means 5 difference is there. 5 second difference is there. Means at every 5 second velocity is 9 meter per second. Okay. So 18 minus 9 gives you 9 meter per second. Velocity is changing. That means it is a not uniform motion, but velocity is changing uniformly. This is the example of uniformly accelerated motion. When you plot the graph, you can see 5 second velocity is 9. After 5 second velocity is 18. After 5 second the velocity is 27, so on. In VT graph, you will get a straight line. So this is the example of uniform acceleration motion. Okay. In VT linear graph, constant acceleration. Uniformly acceleration motion means constant acceleration. So graph of zero acceleration means here is one graph is plotted. Here velocity is given and here time is given. Okay. So the velocity is parallel to time axis. So what will be the acceleration? How much is the acceleration? The answer for is 0. Why? What do you understand by this graph? Here, time is increasing, but the velocity is not increasing. The velocity is constant over here. So that's why the line is parallel. Okay. For example, this is the graph of velocity is 2 meter per second. Then 0, 1, 2, 3, 4, 5, 6. 1 second velocity is 2 meter per second. Then next second the velocity is again 2 meter per second. Same till 6 it goes on. So here the velocity is constant. So when velocity is not changed, then from where we get acceleration? This graph is called zero acceleration. VT graph slopes gives us acceleration. Can we find out displacement under VT graph in uniform motion? Suppose this is the graph. Here 5 meter per second and here 10 meter per second. Okay, velocity on y-axis. Y-axis, and this one is x-axis. So 1, 2, 3, 4. This is the time. So how you are going to find out the displacement of this graph? The object is moving in a constant velocity. So how you are going to find out the displacement of this graph? What is the formula for velocity? Velocity is equals to displacement upon time. Velocity formula is displacement upon time. So velocity you know, time also you know. If you know velocity and time, then easily you can find out displacement. So displacement we have to find it out. So displacement is equals to velocity into time. So v was 10 meter per second and this one time is 5 seconds. So 10 into 5 gives 50. Okay. So this becomes the rectangle. See this one. This was the example, isn't it? So here we have used the rectangle formula, length into breadth. Okay. We know time and we know velocity. So we are going to multiply this both term. 10 into 5 gives you 50. Okay. So rectangle area formula is length into breadth. So area under graph, the area which cover under the graph, this part, we have calculated the area. We can find displacement under VT graph. In VT graph, we get the slope that is of acceleration, and also we can find displacement under VT graph. So this was about velocity time graph.